So here we have the 2010 Intermediate 2 Physics question 21, where it says, a balloon of mass 400 kilograms rises vertically from the ground. The graph shows how the vertical speed of the balloon changes during the first 100 seconds of its flight upwards. So we look at the graph, it seems to start with a speed of 0 meters per second, and the speed increases up to a speed of 6 meters per second, and it took 60 seconds to do that. And then it continues rising upwards, where its speed remains at 6 meters per second for the next 40 seconds, so the total time of flight is 100 seconds. Question A. Calculate the acceleration of the balloon during the first 60 seconds. So we're only going to that point there, the 60 seconds. So let's start with writing down, what do we know? Well, we know the initial speed is 0 meters per second. The final speed was 6 meters per second. And the time taken for that change in speed was 60 seconds. And we wanted to calculate the acceleration, which of course is in units of meters per second per second. Now, looking at the formula book, acceleration can be calculated by final speed minus initial speed divided by time taken. We know final speed, we know initial speed, and we know the time taken. So A equals 6, take away 0, divided by 60, so the acceleration up the way is 0.1 meters per second per second. The next question says, calculate the distance travelled by the balloon in 100 seconds. Well, we know that the distance travelled, if you've got a velocity time or a speed time graph, is the area under the graph. So we're looking at this triangle, the area of this triangle, and the area of this rectangle. So let's show off to the examiner and say that the distance travelled is equal to the area under the graph. So the distance equals a half times base times height plus length times breadth. And I'm just going to draw the triangle there and draw the rectangle there. So if we go back up and have a look at it, the base of the triangle is going to be 60 and the height will be 6. So we've got equals a half times 60 times 6 plus, if we look at the rectangle, and this is where lots of people make a mistake, this is 40 here, it's 100, take away 60, it's 40 multiplied by 6. Whoops, go back up. So it's 40 multiplied by 6. So this bit's 180, check with your calculator. This bit should be 240 plus, add them together, the total distance travelled during the 100 seconds is 420 metres. The next part of the question says, calculate the average speed of the balloon during the first 100 seconds. So the average speed now, you should all know that the average speed is the total distance travelled divided by the total time taken. So average speed equals distance divided by time. Well, we know the distance, we worked that out in the last question, is 420 metres. The time, the total time for that whole journey was 100 seconds. So the average speed is 4.2 metres per second. Another 2 marks. Question D says, calculate the weight of the balloon. Now I'm needing to go back and see what information it gives us. Well, we know the mass, and it doesn't say anything about it being on a different planet. In fact, hot air balloons only work on Earth because they have an atmosphere with air in them. So let's again write down what we know. We know the mass of the balloon is 400 kilograms. We know gravitational field strength on this planet that we're on is 10 newtons per kilogram, and we're trying to work out the weight of the balloon, which of course is measured in newtons. Again, when we go to our formula book, it tells us that W equals m times g, which is 400 times 10 is 4,000 newtons. And this information can be found at the front of the exam paper, if you're wondering where I got it from. The last question says, calculate the total upward force acting on the balloon during the first 60 seconds of its flight. This is going to require a diagram. The weight of the balloon is 4,000 newtons. Just to balance that weight, if it wasn't balanced, a hot air balloon would of course fall downwards. So we need to balance that force. So it needs balanced by at least 4,000 newtons acting up the way. But of course during the first bit of the flight it accelerated up the way, and it accelerated at 0.1 metres per second. It had a mass of 400 kilograms, so the unbalanced force to cause that acceleration is m times a, which is 400 times 0.1. It had an unbalanced force of 40 newtons. So we need another 40 newtons there. So the total force up the way is the 4,000 plus the 40 to give us 4,040 newtons. That question is worth 3 marks because you need to remember the weight of the balloon acting down the way. We need to balance that force and then get the additional force which causes the acceleration.